In this video, we're going to learn how to solve side-angle-side triangles using the law of cosines. Now, I wrote the law of cosines in the top left here for easy reference. And now we're going to get into how to solve these triangles. Now, in previous lessons, we've talked about angle, side angle, angle, hypotenuse leg, and side angle cases for triangles. And the law of cosine addresses side angle, side, and side congruent cases of triangles. So first, we're going to talk about the side angle, side triangles. So each of these triangles below are in a situation where you have two sides and the angle between them. So writing this down, I'll say this is angle A, angle B, and angle C. And I'm given side A, which is 2, side B, which is 3, and angle C, which is 60 degrees. And I'll be looking for angle A, angle B, and side C. Now, first I'm going to find side C using the law of cosines. So I want to know what side C is. So C squared would be equal to A squared plus B squared minus 2AB cosine of angle C. So C squared is equal to 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of 60 degrees. So as I go through, I'm going to plug these in. So C squared will be equal 4 plus 9 minus 2 times 2, which is 4 times 3, so 12 cosine of 60 degrees. C squared will equal 13 minus 12 cosine of 60 degrees, which I will now plug in. And actually the cosine of 60 degrees, I don't even need a calculator for this one, is 1/2. So C squared is equal to 13 minus 12 times 1/2. That's one of those unit circle values, giving me C squared is equal to 13 minus 6. C squared equals 7. So C is equal to the square root of 7. So I found one side already. Now going on, I could use the law of sines to figure out these other two angles, because now I have a pair of C and C. But I want to show you how you can also use the law of cosines to find an angle as well. So I will look for angle A, which I would need to get cosine of A to show that. So to rewrite this formula, if I want A as my angle here, I'll just write A squared and then cosine of A, and I'll replace the A and B with B and C, the other two sides. So B squared plus C squared minus 2BC. Now how this will help me is now I know what side C is, and I know what side B is, and I know what side A is, so I can look for angle A. So plugging everything into that formula, side A would be, I'll rewrite the formula here for a second. A squared is equal to B squared plus C squared minus 2BC cosine of A. So that gives me 2 squared minus, or equals 3 squared plus square root of 7 squared minus 2 times 3 times the square root of 7 cosine of A. So 2 squared is 4 is equal to 9 plus 7 minus 6 square roots of 7 cosine of A. Combining my like terms, I can get 4 is equal to 16 minus A little mistake there. 16 minus 6 square roots of 7 cosine of A. Subtract 16 gives me negative 12 is equal to negative 6 square roots of 7 cosine of A. Dividing by that gives me 2 over the square root of 7 is equal to cosine of A. But I want to figure out what angle A is. So by rationalizing my denominator, I will now take the cosine inverse of that value. And A would be equal to cosine inverse of 2 square roots of 7 over 7. This one I will need a calculator for. So cosine inverse of 2 square roots of 7. Is that too many parentheses? No. Divided by 7. Give me 40.89 degrees for the angle. And again, I'm in degree mode to make that happen. So 40.89 degrees. So A is 40.89 degrees. And now to find angle B, the last remaining angle, I can just use the fact that these should all add up to 180 and find angle B. So B is equal to 180 minus 40.89 minus 60 degrees. All of these are degrees. So 180 minus 40.89 minus 60 gives me 79.11 degrees. My example on the right, I'm given a more obtuse angle in between the two sides. So this is angle A is 120 degrees. And I'm looking for angle B and angle C, and I'm given sides B and C. And I'm looking for side A. So again, I'm going to find that side A first using that formula. So I know that A squared is equal to B squared plus C squared minus 2BC cosine of A. So A squared is equal to 4 squared plus 1 squared minus 2 times 4 times 1 cosine of A, which is 120 degrees. So A squared is equal to 16 plus 1 minus 8 cosine of 120 degrees. So I get A squared is equal to 17 minus 8 times cosine of 120, which is another unit circle value, known as negative 1/2. And I get A squared is equal to 17 plus 4. And again, just to double check that that is a unit circle value, you can always plug it in. So if I did cosine of 120, it'd be negative 1/2 as well. So then A squared is going to equal 21. So A is equal to the square roots of 21. And now look for the remaining sides. Now this time, to find the remaining sides, instead of using the law of cosines again, since I have a pair of A and A, I'm going to use the law of sines to find the other two angles. So I can say sine of A over A is equal to sine of B over B. And I can also say sine of A over A is equal to sine of C over C. Plug in the values for A, I get sine of 120 degrees over side A, which is the square root of 21. It's equal to the sine of B, which is, I'm looking for that angle, over 4. So I can say that sine of B is equal to 4 sine of 120 degrees over the square root of 21. And that value is equal to 4 sine of 120 degrees divided by the square root of 21, 0.756. And then I could take the sine inverse of that to find the angle. Which would be 49.11 degrees. We talked about in a previous lesson that there could be an ambiguous case whenever you take the sine inverse, but since this is one of those cases that gives me a unique triangle no matter what, I don't need to check for that additional triangle. It won't exist. And again, solving the other equation, I'll get sine of 120 degrees over the square root of 21 is equal to sine of c over 1. Cross multiplying, I can get sine of c is equal to the sine of 120 degrees over the square root of 21. The value of that is, let me plug that in, 0.189. So now I can say c is equal to sine inverse of that value to find the angle for c. And I get 10.89 degrees. And if you want to double check that is the correct answer, these should all add up to 180. So 120 plus 49.11 plus 10.89, you get 180 as well, which solves the triangle. So I find every angle and every side. And that is how you solve side angle side triangles using the law of cosines.